In this video, we're going to be looking at graphing absolute value function. If you find this video helpful, share, like, and subscribe. Okay, absolute value functions. These are very important functions because they are actually defined by a piecewise defined function. So we're going to be looking at more on this, another type of function in our next lessons. Now, for you to enjoy studying about this function, I would like you to look at some of its characteristics. Okay, so in this graph of this function, absolute value function, the very first thing that's going to be very noticeable in here is actually the shape of the graph. Okay, the shape of the graph is like in a V shape, right? So from the start, and then it's going to be going up in here on one on the right side, one on the left side. So this is one of the very nice feature of this absolute value function. It's a V shape. But also I would like you to look at the vertex. The vertex of the parent function is actually located at 0, 0, or we call it the point of origin. Here, now about the domain. The domain, it represents the x values, while your range represents your y values, okay? Now, it is important for you to know the domain of your function for you to understand how it behaves. So, on the left side, you're going to have your negative infinity, and on the right side, you have your positive infinity. So, if you're going to look at your graph, the V-shaped graph, okay, it's actually coming from this side. So, from this side, that's actually your negative infinity, and it's going to stop at the middle part, or you call it the point of origin, and from the point of origin it's gonna start going up again, going to what you call positive infinity. So that's what it means when you're going to understand the domain of your function. Regarding the range is the y. Range is the y values. If you're going to be looking at the range in here, the range is from 0 to infinity only. It means to say that starting from 0 and it goes up this way, okay, because your function goes this way and goes that way. And look at this one, your y values is also going up and up to the infinity. So this is going to be your positive infinity, and the lower part of your y-axis is going to be your negative infinity. Okay, another thing that you're going to look at is what you call the intercepts. Okay, the intercepts is also located at your 0, 0, or we call it the point of origin. Now, let's understand this word. It means decreasing here. Look at this word. Decreasing on negative infinity 0, and it increases on 0 infinity. So what that means is very simple. It means that if you're going to look at your graph, okay, here, starting from your left side, remember that this is your negative infinity, and this is going to be your positive infinity, the right side of your graph. Now, if you're going to be looking at the direction of your graph from here, it's going to reach 0, all the input values here is going to be decreasing, okay? It's going to be decreasing from negative here, negative infinity, going to 0, okay? And once it's going to reach 0, what will happen is that from 0, it's going to go up again to infinity. That's why it said from 0 to infinity, it's going to be increasing on this area. Now, from 0, you can see that the values of your x in here is going to be increasing also. That's what it means when we say decreasing on negative infinity 0 and increasing on 0 infinity. Okay, so let's look at some transformation vocabularies in here. Okay, I would like you to take note of the function. So the function in its fullest version is actually written as f of x is equal to negative a, the absolute value of negative bx minus h plus k. Now, all of these variables are actually used for transforming our absolute value graph. So for some starters, first we're going to look at the transformation, and then the notation, and we're going to look at some examples for us to understand our lesson today. Okay, so when we say horizontal translation, the keyword here is translation. It means you're going to move from one place to another. It means to say that from 0, 0, you can move it left or right. Therefore, it says here that the graph shifts from left or right. Now, how are you going to know that there's going to be a horizontal translation going on? The way we write our translation in here is going to be x minus h, or it can also be written as f of x plus h. Okay, now let's look at this example in here. So say for example, we're going to translate from f of x minus h. We're going to now write g of x is equal to absolute value of x minus 2. Now this minus is going to actually present or represents the right side of your graph. Okay, so example, you're going to have your f of x as your parent function in here. This is your f of x is equal to absolute value of x. Now if it is going to be g of x is equal to absolute value of x minus 2, it means to say that that's going to be moving. Okay, here, let me write it from here. So from here, it's going to move 2 units from the center going to the right side of your graph. So it's going to be having the same shape like this, but the location is now moved from 0 to 2. Okay, so that's going to be what you call your right 2 units. And the next one is the opposite, of course. That's going to be on the left side. So how do we know that it's going to be moving to the left side? Because of the way we write it, we use plus instead of minus. That's gonna represent left side. Okay, so let's give you an example once again. So it's like, just for this example, you have here absolute value of x plus 3. Now remember that our parent function starts from 0, 0. It goes this way, yeah. Okay, so you can see that there's going to be the 0, 0. But this time, if I'm going to say x plus 3, it means to say that it's going to move from the center, here from the center, going to your left side with 3. We call it specifically negative 3 units. So what happens now if I'm going to redraw my graph in here is that it's going to shift, or it's going to move 3 units to the left. Okay, so let me just continue here. So now you have here your absolute value. What happened is it's going to go 1, 2, and 3. So this is now your vertex, and it's going to go move it this way. So what did you notice? This is actually called a horizontal translation of 3 units, or yeah, 3 units left. Okay, so next, let's look at the second part of your translation, which is the vertical translation. Now, vertical translation says here that the graph shifts up or down. But how do we know whether it's gonna go up and down? Now, let's look at the notation. The notation for going up is the f of x plus k. Okay, that k represents a unit going up to your y-axis. Okay, what about down? It's going to be f of x minus k units. It means it goes down. Okay, so let's look at this example in here. G of x is equal to absolute value of x plus 7. So this means that when you see that the f of x, okay, let me just use a little space here. So remember our f of x. Okay, our f of x is equal to the absolute value of x. Okay, and that's going to be the parent function, and the parent function is actually at the 0, 0 here. It's gonna go this way, right? Okay, now when we say plus 7 units, it means it's going to go up 7 units up. Okay, so let's say this is going to be 7. So from here now to the center, it's gonna go up 7 units. So it's going to end up at 7, and still it's going to be having the same shape. So that's what you call up 7 units. Now the down is also the same. It's still going to retain its shape as the mother, but in this case, just like this one, absolute value of x minus 1, it means that it's going to go down 1 unit. So it's going to be just simply going down, just say 1 unit here, say this is 1 unit, and from the parent function it's going to carry the same shape, okay, but it's just shifted 1 unit down. So this is what you call vertical translation. Okay, so let's look at your reflection. Reflection happens when here, if you're going to look at your A in here, when the A is going to be a negative, or when your B in here is going to be a negative value. Okay, so let's look at reflection. It says here that reflection, it means that the graph is going to flip over X or Y axis. So how do we know when it's going to be reflecting across Y axis or it's going to be reflecting across X axis? Well, look at the notation again in here. The notation for reflection across Y axis is that the negative is actually inside your function, okay, inside the parentheses, I mean. So just like this one, if you're going to be looking at this one, there's the parentheses in here, but you can see actually the absolute value, okay, and that negative here is actually representing the negative B, okay. So let me just put a little here. Let's say this is going negative bx, okay, something like this. So what does this mean? It means that the reflection is just happening within the y-axis. So okay, let me just take it. Okay, imagine that you only have this shape, okay, and if sometimes you don't even notice that there's going to be a reflection, because if this is going to flip over and the other one is going to be flipping over, they are going to retain the same shape. That's why in the naked eye you cannot really see a little bit of this so-called reflection. However, if you're going to be looking at the notation where the negative is actually outside the function here, just like this one, the negative is outside the function, okay, and it's going to be written like the negative of absolute value of x, then this is going to be a reflection over the, or sorry, across the x-axis. Okay, so let's look at this one. So imagine this one in here. You have your parent function in here, which is actually going up. This parent function is actually f of x is equal to absolute value here. F of x is equal to the absolute value of x. Now, what if I'm going to put a negative number in front of it? What happened is it's gonna be reflecting across x-axis. So negative absolute value of x is now going to be reflecting in here. Yeah, this one, it's exactly the same thing, but it just reflect across x-axis. So this blue line already is now going to be your f of x of negative absolute value of x. Okay, let's go for the horizontal shrink and stretch. Okay, this is characterized by the b again. So if you're going to be looking at our function in here, we have actually the b in here. So that b is going to be representing the horizontal stretch or shrink. Now in here it says that the stretch or shrink factor is 1 over b. Okay, I just would like you to take hold of this for a bit. I'm going to show you a little bit. Now when we say horizontal shrink, okay, or stretch, the stretch here it's going to be stretches away from the y-axis, while shrink is going to be shrinking towards y-axis. Okay, so let's look at some example in here. So example in here, you are given g of x is equal to absolute value of 3x. Now in this case, remember earlier that I told you to hold on to this. Okay, that's going to be your shrink or stretch factor. So let's look at this g of x in here. The g of x, what is the value of our b in here? In this case, the b is equal to 3, right? So if I'm going to put that in our shrink or stretch factor 1 over b, okay, so this is going to be 1 over 3. Now 1 over 3 is now going to be what you call, it's shrinking by a factor of 1/3. Okay, that's what I meant earlier when I told you that the shrink or stretch factor is absolute value of 1 over b. Okay, let me give you an example. Okay, another example of a horizontal shrink is, say, f of x is equal to, let's say, I'm going to say 4x. Okay, So what is the value of my b in here? The value of my b is 4. Now, I'm going to put this b into my shrink factor or stretch factor of 1 over b. 1 will remain there. And what's the value of my b? It's 4. Therefore, it's going to be a factor of 1/4. That's how we describe it. Now, what about horizontal stretch? Now, look at what's inside this one. The b in here this time, the value of your b in here this time is actually less than 1. Can you see that one? 1/2 is less than 1, yeah? But we're still going to use our shrink stretch factor of 1 over b. How did we get 2 in here? Okay, so here, our b in here is what? The value of our b is 1/2, right? Now, let's put it to our shrink stretch factor of 1 over b. Okay, that's gonna be 1. Okay, what is our b? It's gonna be 1/2. Okay, so here, what is 1 divided by 1/2? 1 divided by 1/2 is equal to 2. Here, it's just like saying 1 all over 1, and then we're going to divide that by 1 over 2. Okay, in your earlier mathematics, we said that we're going to get the reciprocal of this, and we're going to change this one into multiplication. So 1 over 1 multiplied by the reciprocal of 1/2 is 2 over 1. Now, multiply them, it's just going to give you 2 over 1, and 2 over 1 is the same as 2. That's why it's called a horizontal stretch by 2. So remember this one, that when the b is bigger, it's gonna shrink. When the b is less than 1, it's gonna stretch. Okay, so the last one is called the vertical stretch or shrink. Vertical stretch or shrink it means that the graph stretches away, okay, away from the x-axis and shrinking towards x-axis. So let's look at the notation. The notation is a, any number a multiplied by your function. Remember, your function here is the absolute value function, okay? We have to write it this way. A multiplied by, let's say, a multiplied by your absolute value function. That f of x represent this one. Okay, so let's look at some example. Look at this one. It's gonna be a vertical stretch by 4 when you can see that the 4 is outside your absolute value function. This one alone is going to tell you that there is a vertical stretch by 4. What did you notice with the value of a? The value of a here is greater than 1, okay? In this case, 4 is greater than 1. So we can say that when a is greater than 1, then it's going to have vertical stretch by that factor of a, which is in this case, it's 4. The opposite, let's look at the opposite. Here in this case, you can see that 1/5 is actually less than 1, it's less than 1. Therefore, we can say that if the value of a is less than 1, then it's going to have a vertical shrink by that same factor. Okay, I'll give you more examples. Let's say f of x is equal to, let's say, 10 absolute value of x. So this function means that this is greater than 1. A is greater than 1. In this case, 10 is greater than 1. Therefore, what did we say? If a is greater than 1, then that's going to be a vertical stretch. So there is a vertical stretch by factor of 10. This one. Okay, another example. Let me just go out of the paper. Okay. Let's say f of x is going to be 1 over 88. Okay, the absolute value of x. So in here, we can say that there is a vertical, okay, vertical shrink. Okay, it's actually a vertical shrink by 1 over 88. Okay, so why is that? Because 1 over 88 is less than 1. Here, in case that a is less than 1, therefore, it's going to have a vertical shrink. Okay, so I hope you have understood these terminologies that we have learned today. Okay, if it's still very confusing on your part, please go back over and over to this part of the video. Consider the function f of x is equal to a absolute value of bx minus h plus k. Okay, here we're going to begin graphing f of x is equal to absolute value of x. Okay, so remember in our earlier part of this video, we said that the parent function is actually starting from 0, 0. Okay, this one. Okay, so to graph the function absolute value of x, okay, we said earlier in this video that the vertex is going to be at 0, 0, and this is actually what you call your parent function. Okay, now let's graph f of x is equal to x minus 2. Now, what transformation happened in here? There is a horizontal translation of to right. So that means we're going to start from 2. So from here, 1, 2, this is going to be our vertex already. Then we're going to graph that part. So here, I'm just going to create a small line here. Okay, on the other side. Okay, so not so accurate, but at least you have an idea what it is. So, okay, this is your f of x is equal to absolute value of x minus 2, where there is a horizontal translation of 2 units right. Okay, finally, let's graph f of x is equal to absolute value of x plus 4. Here we can say that there is also a horizontal translation of 4 left side. So in that case, from 0, 0, it's going to go 4. So here, 1, 2, 3, and 4. So this is your 4. Okay, so let's graph this part. Okay. Let's just connect this one. Okay. And the other side again. Okay, it's going to be on this side. Okay, there you go. So you have an idea. Said that there are no more graphs on this side. So that is the graph of this f of x is equal to x plus 4, having a horizontal translation of 4 left. Okay, let's try one more. Negative absolute value of x. This negative is going to tell me that there's going to be a reflection across x-axis. Okay, so let's try to look at our parent function first. So our parent function actually starts from the center, true? Okay, from 0, 0. So if we're going to be doing from 0, 0, okay, may not be very accurate, but at least we have a basis on how to see this one. Okay, so I'm going to use green color in here. I'm just graphing the parent function here. Okay, so the green is going to be my parent function. This is going to be represented by f of x is equal to the positive absolute value of x. Now I'm going to graph my negative absolute value of x using different color this time. I prefer the red color. Okay, so if we're going to do that, it's gonna be starting from our origin again. That's it. And the other side. Okay, so something like this. Okay, this is now what you call your f of x is equal to negative absolute value of x, which is called a reflection over the across the x-axis. Okay, the next one. Now graph f of x is equal to absolute value of x plus 3. Now in here, I can see that there is actually a vertical translation. Yeah, there's a vertical translation of here. How many units? 3 units. And because it is plus 3, it means it's gonna go up the y-axis 3 units from 0. Okay, let me just quickly graph my parent function in a dotted line. I would like to use the black this time for the parent function. Okay, this is my parent function. The other one should be on this side. Okay, it's not accurate, it's not perfect, but at least you can see what I'm talking about here. Okay, now let's go up from 0, let's go up to 3. So from here now, I'm going to use blue color this time. Okay, so from here, I'm going to do the same thing, the same shape. Nothing has been changed yet. Okay, here, and this is gonna be my f of x of absolute value of x plus 3. It means vertical translation of 3 units up. Okay, so I hope this is very clear example to you now. Okay, finally, let's graph our f of x is equal to absolute value of x minus 2. Okay, so let's graph our parent function for the meantime here. Okay, parent function starts from 0, 0 all the time. Okay, so I'm going to just use blue here, but it's gonna be a dotted line. Okay, this one. Okay, so that's gonna be our parent function, which is f of x is equal to absolute value of x. Now there is actually a vertical translation of 2 down. Okay, so it means to say from 0, 0, it's gonna go down to 2. So here's gonna be my vertex now. Now I'm still going to be doing the same thing, copying the same shape of the graph like that of the parent function. It's just that it's actually shifted 2 units down. Okay, here, so let me just do it this way. Okay, as I said, it's not perfect. I hope you can bear with that. The other side, let's graph the other side. Okay. Okay, there you go. One more. Okay, here. Oops. What happened? Okay. Okay, so that's what we meant by this one. Okay, what else? Now let's do this one. Okay, so first let's remember the translations that happened, or sorry, transformation that happened here. Okay, first I've seen a negative in here, which means it's gonna tell me that there is a reflection here, and then there's going to be a horizontal translation in here of 2 units to the right, and there's going to be a vertical translation of 3 units up. Okay, let's label that one. This is going to be a reflection over x-axis. Okay, this one, this 2 in here is going to be a horizontal translation of 2 right, and this is going to be a vertical translation of 3 up. Okay, so let's find our vertex. In this function, the vertex is actually located at, this is going to be 2, and then this is going to be 3. This is going to be our vertex. 2 and then 3, this is 2 and 3. Since it is reflection, so instead of going up, it's gonna be opening down. It goes this way. Okay, and this way. Okay, so this is how you're going to graph it. Okay, the next one. Now graph f of x is equal to 3 absolute value of x. So in here I can actually see a vertical stretch by 3. Okay, so let's draw first our parent function. Our parent function of let's say not g of x, should be f of x first. F of x is always x, and then let's try this one as g of x. Okay, and the other side, let me draw the other side, this one. So this is your parent function. So if you're going to be having a vertical stretch by a factor of 4, it means to say that's going to be, it stretches away from the x-axis. So from the x-axis here, then it's going to be steeper. So if I'm going to draw this one, this is not very accurate. Okay, it's going to be steeper by this one. Okay, that's called, it stretches. It means to say that from the parent function as your basis, it's now going away, all the way that away from the x-axis. Yeah, that's going to be away from the x-axis. That is what you call your g of x is equal to 3, or vertical stretch by 3 times the absolute value of x. Okay, finally, let's graph this function. Okay, f of x is equal to negative 1 over 3 times the absolute value of x. Now, I can see in here a reflection across x-axis, and then I can see a vertical shrink of by a factor of vertical shrink by 1 over 3 and nothing more. Okay, by 1 over 3 only. Okay, so in this case, let's let's draw again our parent function in here for you to understand. Oops. Okay, so this is our parent function. Let's call this f of x is equal to absolute value of x, and we're gonna change this to g of x. Now, this is a vertical shrink. So when you say vertical shrink, it is going, or it shrinks towards the x-axis. So since there is a factor of 1/3 as a vertical shrink in here, yeah, there's a vertical shrink. Vertical shrink is going, or is going to be going towards the x-axis. So from the parent function, it's gonna go towards the x-axis. So if we're going to roughly graph this one, it's gonna be something like this. Yeah, so it's going to be wider than the original function or the parent function. So this is the effect when a here is less than 1. It's going to become wider and wider, and it's always towards the x-axis. Okay, so this is what you call the vertical shrink. Okay. Okay, so returning to f of x is equal to ax minus h plus k, how does each variable affect the parent function f of x is equal to absolute value of x? So when positive is a, what will happen? When the positive is a, it's going to open up. Okay, so it goes this way. When a is negative, it's going to open down. Okay, it goes this way. Okay, when h is positive, where will it go? When h is positive, it's gonna go right. Okay, when h is negative, it's gonna go left. When k is positive, it's gonna go up. And when k is negative, it's gonna go down. Okay, so I hope you will remember all of these things that you have learned from this video. The point where the two linear pieces intersect is known as the vertex. So using the variables above, the vertex can always be found at one point. What point? It's the point of intersection. Okay, you can always find the vertex at the point of intersection of the two linear pieces. Okay, so let's do some practices about describing the transformation that happens for each item in here. Let's go for number 1. F of x is equal to x minus 2. the transformation that happened here is actually a horizontal. This one is going to be a horizontal translation of to right. Next one, f of x is equal to absolute value of x plus 3. Okay, I can say a vertical translation. Vertical translation of 3 units up because of the plus sign. Next, we're going to look at number 3. F of x is equal to 2 times the absolute value of x plus 3. So I can see in here a vertical stretch and a horizontal translation. So a vertical stretch by 2, that's the first one, and the second one is a horizontal translation of 3 units. It is plus, so it's gonna be on the left side. Okay, next, number 4. F of x is equal to 3x. No horizontal or vertical translation. We only have the vertical stretch by a factor of 3. So there is a vertical stretch by a factor of 3. Okay, number 5. F of x is negative 2 times x, absolute value of x plus 3 minus 1. So the first thing I notice is the negative in there. It means there's going to be a reflection across x-axis. Across x-axis. The second that I notice is the plus 3 in there. That's going to be a horizontal translation of 3 left side, left. And the last one is negative 1. That's going to be a vertical translation of 1 down. Okay, it means 1 unit down. Okay, next, f of x of 2 times the absolute value of x plus 8. Okay, 2, and this one, this is going to be a vertical stretch again. Vertical stretch by 2. And the other one is vertical translation 8 units up. Okay, next one. Write an equation for absolute value function described. Number 7. The parent function f of x is equal to absolute value of x flipped and shifted up 3 units. When it says flip, it's a reflection. It's gonna be a negative. And shifted up, it means plus 3. Okay, so let's write the... So we started using f of x as the parent function. Now we're going to use another letter. Here, I'm gonna use g. G of x now is going to be the absolute value of x. Now it's flipped, so I'm going to say negative absolute value of x. And then shifted up 3 units. That's going to be plus 3. This is the answer to this exercise. Number 8. The parent function f of x is equal to absolute value of x squeezed by a factor of 2, shifted left 3 units and down 4 units. Okay, so let's look at the keywords that they gave us here. Squeezed by a factor of 2. So that's going to be within the x. This is going to be b is equal to 2. Shifted left 3 units. So that's going to be plus 3. And down 4 units is going to be minus 4. So f of x, that's the parent function. We're going to use g of x instead. This is going to be the absolute value of 2x and then plus 3 and then minus 4. Now remember that this is going to be the b, and to measure up our stretch or squeezed, in this case, we always use the absolute value of 1 over b. In this case, the value of our b is 2. So let's see, if this is going to be 1 all over 2, then it's really going to be squeezed. It's going to be smaller than 1. Therefore, this is the correct answer to our question here in number 8. Okay, number 9. Write an equation. We are asked to write an equation for the graphs shown below. The parent function is f of x is equal to absolute value of x. Okay, number 9. Let's look at number 9. So first, I would like to look at the vertex. Where is my vertex located in here? Okay, that's going to be located at 2 and then 2. Okay, so let's write the function. That's going to be a x minus h plus k. Okay, this will be absolute value plus k. Now, when you're going to be talking about the vertex, this x and y coordinate is actually represented by h and k. That x coordinate is actually related to your h, and that y coordinate is related to your k. So now let's plug in here. So far, our a here is 1 only. It cannot be 0. So absolute value of x, our h here is 2. So that's going to just give you 2. And this is going to be 2 also because it's going to be up. Okay, so this is now your function in here. Okay, number 10. The very first thing I'm going to find is the vertex. The vertex is located at hk, and that hk is actually a coordinate x, y. So in this case, our vertex is located at 0, 0, which is located at the very origin of our graph. Now, another thing that we have to observe is the graph did not pass through 1. So if we are going to be looking at our parent function, it actually goes through 1, yeah, and -1 here. It goes through this path. However, I have noticed that it became more steep. So it means to say that this is going to be a horizontal stretch by a factor of 2. If I'm going to look at this part, okay, let me just show it this way. Okay, so between 1 here, this 1 and 1, if I'm going to get this part, what I can see is just 1/2. Okay, so that means that there's going to be a stretch factor of 2. Now, why factor of 2? Because remember, our b here is equal to 1/2. If we're going to put that in our shrink factor or stretch factor of 1 over b, 1 over 1/2 is going to give you 2. Therefore, it's going to give you a stretch by 2. So now that we know that information, now we can now write our function in here. Okay, so with all of this information right now, it means to say that our b here is 2, so we can now write our function here. Our a is 1. There is no other translations in here, no horizontal translation or vertical translation, but there is a stretch, horizontal stretch by a factor of 2. So we can say 2x. Okay, that is your function in here. Okay, number 11 and the last. First, let's find where the vertex is. Here, the vertex is located at, here, the vertex is located at -3, -1. What else? The graph is opening down. So it means to say that there's going to be a reflection. This is going to be a reflection. Another thing that you have to notice here is the graph is not actually passing through the correct lines in order for it to be recognized as the parent function. Here, if you're going to be looking at this one, it should pass through this line to make it as the parent function. Okay, so did you notice that? This is going to be the original function. F of x is equal to negative absolute value of x and some other numbers in here. Okay, but this time what I'm concerned is that from the parent function, it's actually a little bit stretched in here. So if you're going to notice that from the parent function, the graph is actually shifting towards the x-axis. Yeah, did you see that? See, it's going towards the x-axis. and that is going to tell you that there's going to be a vertical shrink because it's going towards the x-axis by a factor of a fraction. Okay, it's not going to be a whole number, but it's going to be less than a number. So the vertical stretch in here, the vertical or the a factor in here is going to be less than 1. That's why it's going towards the x-axis. Now if I'm going to just put that up again, if I'm going to get this part, okay, this one, okay, this graph actually went halfway, this line, it means to say that's going to be 1/2 of it. Okay, so 1/2 of it, it means to say that there's going to be a what's this, a vertical shrink of 1/2. Okay, so with that information that I have observed, now I can write my equation. Okay, so let's write our equation. Y is equal to, our vertex is located, now it's going to be reflected, so I'm going to say negative, and then x minus 3, because that's my h in there, and this is my k, and then minus 1. Okay, let's continue to simplify them. Negative absolute value of x, negative multiplied by a negative is going to give you plus 3 minus 1. So this is going to be our, but we're not done yet, okay, because what about the vertical shrink by 1/2? So we can say that our final now is going to be negative 1/2 x plus 3 then minus 1. So this is our final equation in here. This is all on this lesson on graphing absolute value function. If you find this video helpful, share, like, and subscribe. Thank you very much.